Let's talk about volcanism and extrusive rocks. Volcanism is the phenomenon of eruption of molten rock onto the surface of the earth, and extrusive rocks are any igneous rock that forms at the earth's surface, whether it solidifies directly from a lava flow or is pyroclastic. What is a volcano? A volcano is an opening in the earth's surface through which molten rock flows out or erupts as lava. When volcanoes erupt, magma moves upward from a magma chamber and into a vent. It flows out from a crater at the top, or sometimes emerges at a secondary site on the side of the volcano, resulting in a flank eruption. Erupted materials accumulate around the vent, forming a volcanic mountain. The accumulated material might consist of layers of solidified lava called lava flows, but it also might include fragments of various sizes that have been thrown from the volcano. The difference between crater and caldera. Crater is a basin-like depression over the vent at the summit of the volcano, while caldera is much larger than the original crater, having a diameter of at least 1 kilometer. Let's go to the relationship between plate tectonics and volcanism. Volcanoes are formed in three main plate tectonic settings: volcanism related to divergent plate boundaries, volcanism related to convergent plate boundaries, and volcanism related to mantle plumes. Divergent plate boundary. You can see that there are cracks in the crust and also a rift valley where the crust is ripped apart and it sinks down to form a valley that will allow magma from the mantle to rise up. In either of these situations, we get volcanoes to form. What happens is decompression melting. It is the separation of the plates depressurized the mantle underneath. Convergent plate boundary. The ocean floor is subducted underneath the edge of a continent. The water mixes with the mantle, which lowers the melting point of mantle rocks, causing magma to form. This process is called flux melting, and that magma rises and a whole series of volcanoes begin to form along the edge of the continent parallel to the ocean trench. We call this as continental volcanic arc. Another is instead of ocean floor subducted underneath the continent, we could have ocean floor subducting on another ocean floor. The same process happens. Mantle plumes. The other source of volcanic activity on Earth are what we call hotspots. Hotspots are situations where magma form in just one area. These hotspots form because of large blobs or columns of magma that rise from deep in the mantle. We call these mantle plumes, and as tectonic plates move across mantle plumes, volcanoes are made. The volcano will get carried away, another volcano will form, and yet another volcano will form, and a chain of hotspot volcanic islands are formed. Let's now move on to the types of volcanoes. Shield volcanoes are the largest volcanoes and are mostly associated with mantle plumes. They are broad and gently sloping. They are built of successive flows of low viscosity basaltic lava. The low viscosity of the lava means that it is fast flowing, therefore flows for long distances, resulting in the greater sizes of volcanoes compared to other volcanoes. Example is Mauna Loa, which is the largest of all shield volcanoes, in fact, the largest of all volcanoes on Earth. Composite volcanoes, also referred to as stratovolcanoes, are the next largest volcanoes and are normally associated with subduction. Unlike shield volcanoes, composite volcanoes have a distinctly conical shape. They are formed from layers of lava alternating with layers of tephra. Examples of composite volcanoes are some of the Earth's grandest mountains like Mount Fuji. Lastly are the cinder cones, also called spatter cones. They are the smallest volcanoes and can be formed in various volcanic settings. Unlike composite volcanoes, cinder cones have straight sides. As lava is erupted, it breaks down and falls as cinders. Example is Mount Capulin, which have straight sides and are typically less than 200 meters high. Let's go to the factors influencing the violence or explosiveness of volcanic eruptions. Viscosity is the fluid's resistance to flow. The higher the viscosity of the magma, the more violent it is. Factors affecting viscosity. Silica content. Higher silica content produces higher viscosity. Temperature. Hotter magmas are less viscous. Amount of dissolved gases. The more dissolved gases, the more viscous the lava. There are three types of magma: rhyolitic, andesitic, and basaltic, each of which have a significant percentage of silicon dioxide, temperature, and gas content, which affects their viscosity. As you can see, rhyolitic magma is the most viscous type of magma, therefore it is the most violent or explosive, while the basaltic creates the most quiet or effusive volcanic eruption. Extrusive rocks. These are any rock derived from magma that was poured out or ejected at Earth's surface. Scientific investigation of volcanism, rocks, gases, and events from observed eruptions are compared to similar lavas elsewhere to infer the nature of past activity. Rock composition. The amount of silica in a lava largely controls not only the viscosity of lava and the violence of eruptions, but also which particular rock is formed. Rhyolite is a silicic rock and light-colored. A basalt has a relatively low amount of silica, and andesite which crystallizes from an intermediate lava. Extrusive textures. Texture is the appearance of a rock with respect to size, shape, and arrangement of its grains. The first one is glassy. Glass without mineral crystals, for example obsidian. Fine-grained are most crystals greater than 1 mm, for example basalt. Porphyritic, larger crystals in a matrix of much finer crystals or glass, for example andesite. Vesicular, frothy, trapped gas bubbles, and fragmental particles blasted apart by explosive eruptions, for example dust and ashes, cinders, and blocks and bombs.
There are several types of volcano eruptions based on the physics and chemistry of the magma. In more detailed classification schemes based on character of eruption, volcanic activity, and volcanic areas are commonly divided into six major types. They are listed as follows in order of increasing degree of explosiveness. Hawaiian eruptions are made after the characteristic of eruptions of volcanoes of the Hawaiian Islands. Hawaiian eruptions are effusive rather than explosive because they erupt low viscosity basaltic lava. Therefore, Hawaiian eruptions form shelled volcanoes. Strombolian eruptions, named for Mount Stromboli in Italy, occur when basaltic lava has higher viscosity and higher gas content. The sticky lava is ejected in loud, violent, but short-lived sputtery eruptions. Clumps of gas-rich lava thrown 10 seconds to 100 seconds of meters in the air accumulate as scoria in a pile around the vent, forming cinder cones. Vulcanian eruptions get their name from the volcanic Italian island of Volcano. Vulcanian eruptions are far more explosive than Strombolian eruptions and can blast tephra and gas to a height of 5 to 10 kilometers. The explosiveness is related to a buildup pressure as the higher viscosity of intermediate silica content lava restricts the escape of gas. Aphelion eruption is associated with explosive outbursts that generate pyroclastic flows, dense mixtures of hot volcanic fragments and gas. The fluidized slurries produced by these eruptions are heavier than air but are of low viscosity and pour down valleys and slopes at great velocities. As a result, they are extremely destructive. A Pleiadian type is an intensely violent kind of volcanic eruption. Pyroclastic flows resulted as did lahars, landslides that form when glaciers melted and turned volcanic ash into mud. Pleiadian eruption clouds can rise into the stratosphere and are sometimes continuously produced for several hours. A more recent Pleiadian eruption was that of Mount Redoubt in 1990 April 21. Hydrovolcanic eruptions can be far more explosive than Pleiadian eruptions. They occur when water in the form of groundwater, seawater, or even melting glacial ice or snow comes into contact with magma. Heat from the magma changes water suddenly to steam, which can expand to more than 1,000 times the original volume of water. The sudden expansion results in an explosive force that can blast a volcano to pieces and create large amounts of volcanic ash. Materials produced by volcanic eruptions: gas, lava, and fragmented debris called tephra. The first material produced by volcanic eruption is the volcanic gas. At high pressures, the gases are dissolved within magma. However, if the pressure decreases, the gas comes out of solutions, forming bubbles. Volcanoes release gases when erupt and through openings called fumaroles. They can also release gas into soil and groundwater. The second material produced by volcanic eruption is the lava. Lava is magma that has been expelled from the interior of a terrestrial planet or a moon onto its surface. Lava may be erupted at a volcano or through a fracture in the crust, on land, or under.
There are four types of lava: the pahoyhoy, aa, blacky lava, and lava pillows. Pahoyhoy can be smooth and billowy. It can also develop a wrinkled texture called ropey lava. Aa is a sharp and splintery, rubble-like lava flow. Blacky lava are sharp-edged chunks of stiff lava, and lava pillows are lava that erupts in water.
The third material produced by volcanic eruption are the pyroclastic materials. These are rocks fragments created by explosive eruptions. Volcanic ashes, lapilli, volcanic blocks, and bombs are all pyroclastic materials. They are classified according to their sizes. Volcanic hazards can be classified into direct and indirect. Direct hazards are forces that directly kill or injure people, destroy property or wildlife habitat. Some of the examples are volcanic gas and tephra emission, pyroclastic density current, and lava flow. Indirect hazard of volcanism induce environmental changes that lead to distress, famine, or habitat destruction. Some of the examples are lahar, sector collapse, debris avalanches, and tsunamis. Monitoring volcanoes and predicting eruptions. There are six most important signs of an imminent volcanic eruption. They are 1. Gas leaks are the release of gases from the magma into the atmosphere through cracks of the overlying rock. 2. Bulging is the deformation of part of the volcano, indicating that a magma chamber at depth is swelling or becoming more pressurized. 3. Seismicity, many small earthquakes indicating that magma is on the move. 4. Seismicity ceases is a sudden decrease in the rate of earthquake activity. This may indicate that magma has stalled and that something is about to give way. 5. Big bump is a pronounced bulge on the side of the volcano, which may indicate that magma has moved close to surface. 6. Steam. Steam eruptions that happen when magma near the surface hits groundwater to the boiling point. With these signs in mind, it is possible to determine the necessary equipment to have and actions to take to monitor a volcano and predict when it might erupt. There are actions we can take to monitor a volcano and predict when it might erupt. Assessing seismicity. This is by using seismometers, which are instruments that detect vibration and can provide an early warning that something is changing beneath one of the volcanoes. Detecting gases. This can be achieved with instruments placed on the ground close to the source of the gases or by collecting samples and analyzing them in a lab. Measuring deformation. This can be achieved with the use of peltmeter, which is a sensitive three-directional level that can sense small changes in the tilt of the ground at a specific location in GPS technology. GPS is more effective than a tiltmeter because it provides information on how far the ground has actually moved. Lastly is to put it all together by combining information from these types of sources, along with careful observations made on the ground and from the air, and a thorough knowledge of how volcanoes work. Geologists can get a good idea of the potential for a volcano to erupt in the near future. They can then make recommendations to authorities about the need for evacuations and restricting transportation corridors.